Okay, Javier Avellaneda from MWCapital. I'm in the portfolio section of mobile. So first of all, I want to welcome all of you for coming to these startup pitches from Collider. The Collider is actually the venture builder of MWCapital, and we are specialized in tech transfer. Actually, what we do is we transfer technology. We match top scientists with entrepreneurs, entrepreneurial talent, in order to transform one technology into a deep tech ready, market ready startup. So we have been in the business for more than 10 years. During this time, we have been able to work with more than 100 institutions from all around Spain, both universities and centers of research, and we have been also able to work with more than 200 projects. From these 200 projects, we have created 49 different teams, and from these 49 different teams, we have incorporated a total of 24 companies. We must say that we have a good survival rate. We have 75 or more survival rate of all the companies. So out of the 24, there are 18 still alive, which in deep tech I think is very, very interesting, and we are very, very happy to say that. We are also very happy to say that we have been contributing to the creation of 232 different jobs positions, direct jobs positions in these companies. We spend a lot of time, a lot of efforts, and a lot of resources in each project that we work for. We are also investing money, not that much, 75,000 euros per project, but it's enough to secure other funding or other sources of financing. During these 10 years, our portfolio companies have been able to raise 60 million euros, more private actually than public. So 35 million euros are from private sources or private investors, and 25 million euros are from public sources like grants or soft loans, for example. So the important is the tractor effect that we generate through our program. It's 70 times the money that we invest. We obtain this money from other sources of finance. In total, our companies have a total valuation of 109 million euros, which is, I think, it's a good number. So how we are achieving these numbers, and what do we do to achieve these numbers? No? We have been developing a methodology during 10 years. Actually, we have been making a lot of changes during these 10 years. And just to tell you very briefly, we need more than 12 months since we see a very interesting technology until we create a deep tech startup. But don't worry, I'm not going to explain all what we do during a whole year. I'm just going to say what are we doing in each of the stages that we have in our program, in the Venture Builder program. So first of all, we are looking technologies in all around Spain, from universities and centers of research, and we are focusing on that technologies that are coming from corporations, or corporations actually has told us to look for, also from investors, so we are working closely with them. So if there is any corporation or investor, please come to us, and we will help you to find these technologies. Once we have these technologies, we make a very, very hard due diligence, technological due diligence. For example, we look for the IP protection of the technology that they already have. We also look for the protection of future developments of technology. We look to the state of the art of the technology. We analyze the use case that the scientists decided to choose, because sometimes it's not the best use case for our technology. And then what is very, very important, we start validating initial traction with corporations. And this gives us a clue of if it's interesting or not for the industry. After the validation, technology validation, we only select a small number of projects to continue in our program. So the next thing that we do is we create teams. My teammates says that we do a matchmaking process. I say that we are making like magic, because we are joining together scientists with entrepreneurs, that these entrepreneurs knows about innovation, knows about managing, and knows about entrepreneurship. It's a very interesting combination, but we are able to make these efficient teams that will continue through the project or through the program. After that, we have the core of our program is a 17 weeks program, very intensive. We spend most of the time with validation with the industry, but to sum up, what we do is create the fundamentals of the future spin-off. After the 17 months, we have an investment committee, there are investors, and they decide, actually it's not us, it's the market now that decide if the product or the technology that they have and these projects are mature enough to be incorporated as companies. And after incorporation, we remain as an investor, quite active investor during the first 2 years of the company. Well, we have some of the companies that we have in the portfolio. Now we have 14, actually, after being able actually to exit partially or totally from 6 different companies of our portfolio. Well, we remain quite active. So today you will see there are 5 companies that are going to present to you. These 5 companies has been incorporated after the Collider program. They are from different industries. You will see that they are in different stages of mature, but they have something in common. They are looking for an investor, and I think this is the right moment or the best place for you to meet them. No? So, well, I don't want to spend more time. I think it's better that you see these pitches, and I hope that you enjoy these pitches and you find them interesting, and also the companies that you find them interesting. So thank you very much. Hope you enjoy and have a good soft summit.
Buenas tardes, yo lo haré en español. Creo que la mayoría del público es hispanohablante, por tanto será mucho más fácil. Soy David Comellas, CEO y cofundador de Oxid, una compañía que está focalizada en generar energía limpia allí donde las redes no son capaces de llegar. Realmente tenemos un problema. Las redes de distribución eléctrica se diseñaron en el siglo XX, pero tienen que enfrentarse a un crecimiento sostenido y exponencial de las demandas energéticas. Es un cuello de botella que solo se puede resolver con generación eléctrica on-site. Os pongo un ejemplo muy claro, como pueden ser los data centers, donde hay esperas de años para conseguir la conectividad eléctrica necesaria. De hecho, en algunos casos se habla incluso de montar centrales nucleares al lado de los centros de datos para alimentarlos eléctricamente. Pero este problema es mucho más grande. Hay problemas de descarbonización de ciertos sectores donde todavía se están usando equipos diésel para alimentar, para generar electricidad, y la única solución realmente es ir a energías limpias. Eso no es una opción, es una necesidad inmediata. Y las energías limpias que tienen capacidad de producir electricidad, digamos, en gran masa, son las basadas en el hidrógeno verde. Pero, de nuevo, tenemos un problema. La fabricación, la producción de hidrógeno verde, pues está muy limitada. Por tanto, nosotros estamos trabajando para esto, estamos trabajando para la soberanía energética y para la energía off-grid. ¿Cómo lo hacemos? Con una nueva generación de celdas de óxido sólido. Son aquellas que son capaces de convertir hidrógeno o combustibles que lleven hidrógeno directamente en energía eléctrica, y como resultado a la atmósfera lanzamos agua. Las nuestras son reversibles, es decir, también son capaces de producir hidrógeno industrial para almacenaje de energía o como componente de combustibles limpios, de forma totalmente reversible. ¿Qué nos diferencia de la tecnología de óxido sólido que ya existe en el mercado y además está creciendo muy rápidamente? Que multiplicamos por 5 la densidad de potencia. Por tanto, en un tamaño 5 veces más pequeño generamos la misma potencia, o 5 veces más potencia a mismo tamaño de celda. Esto está soportado en 3 pilares: el diseño, el montaje y el sistema de fabricación. Los 3 los tenemos patentados. Y, de hecho, aquí podéis ver nuestro prototipo, que está funcionando muy bien en el laboratorio, pero también nuestra planta piloto, porque nuestros equipos se fabrican con impresión 3D. Esto da mucha flexibilidad en el crecimiento y nos permite escalar muy fácilmente la compañía. El mercado es muy grande. Hablamos del mercado soft, de Solid Oxide Fuel Cell, son las celdas de combustible que fabrican electricidad, pero también el SOEC, el de electrolizadores que fabrican hidrógeno. Es un mercado muy grande al que podemos atacar con ventajas clarísimas sobre nuestros competidores en diversos sectores. Somos agnósticos al sector. Empezaremos por puertos, donde ya tenemos un primer acuerdo para descarbonizar puertos. En Europa hay 147 puertos sometidos a normativas de descarbonización para el año 2030 y competimos con otras tecnologías, con las tradicionales de óxido sólido, las tenemos identificadas, tenemos claras ventajas competitivas respecto a ellos, las poliméricas alcalinas y, por supuesto, a las baterías de litio, que se están utilizando también como almacenaje, pero en definitiva no deja más que ser un almacenaje. No es producción y nosotros sí que producimos. ¿Quién lo hace? Pues un equipo experto, después de 20 años de investigación en hidrógeno y en generación de energía desde el Instituto de Recerca de Energía de Cataluña, un instituto especializado en energía y en hidrógeno, del cual somos spin-off. Yo mismo, que tengo experiencia, es mi segunda startup Deep Tech que constituyo. La primera ya está funcionando, después de 11 años también con tecnología avanzada en el ámbito de energía e IoT. Y tenemos, además del apoyo de Collider, tenemos un comité de expertos. Jordi Cano, uno de los cofundadores de Wallbox, que seguramente os suena a todos, y Enrique Lizaso, quizá os suene menos, pero es uno de los nuevos unicornios aquí en España. Nuestro roadmap está claro, estamos buscando 500.000 euros para arrancar la compañía y escalar lo antes posible.
I'm Tomer, co-founder and CEO of Nanocronia. Incorporated in 2023 out of the Collider. We are a spin-out of Universitat Rovira i Virgili and Universitat Politecnica de Catalonia. And how indeed you make the invisible visible. So we consider all other current solutions in the market as similar, same as the canary, the first sensor, right, ever. You put it in a cage, take it down into a mine. If it goes dead, you run away. It is not specific, not selective, false positive, false negative. We've developed a system, unified system, which can accommodate any combination of the four gases: ammonia, methane, hydrogen, hydrogen sulfide, depending on the use case of the client and the pain point. Never mind if the vertical is oil and gas, hydrogen ecosystem, agri-tech, mining, waste disposal, water disposal. And never mind if where at the value chain you are: exploration, manufacturing, transportation, storage, and transportation to the last mile. Our system is TRL8. Our ammonia solution is TRL89. The hydrogen is TRL6. Hydrogen sulfide is TRL5, and methane is TRL4. A little snippet of our dashboard, and basically how we do it. We have a system that is very, very, very selective and very sensitive. When we say there is a certain ppm of a gas, it's actually the ppm, the molecule of the ppm that we measured, and not any kind of mathematical model that extrapolate that, because we have no cross-interference or cross-sensitivity with other gases. We are humidity and temperature agnostic. We are 10 times lifetime of the sensor because we have no consumable. We do that acquisition in real time because of the patented control system that we have. Doing that in real time allow us to do lots of nice stuff when we install matrix of sensors. We can do leakage detection, heat map, and also involve AI, put some predictive maintenance into this. Everything is continuously monitoring 24/7, and to couple all of that, the total cost of ownership is very low. We just finished an extensive pilot, industrial-grade validation with our friends from Costa Food in the agri-tech industry, and we are inside the pilot with Repsol Fundación. The Costa was with the ammonia system. Repsol would be with the hydrogen system. 4 patents protect our core technology, and we just pushed another new one into the pipeline a month ago. We have a very balanced team, very good R&D team led by our co-founders and the fantastic R&D team that they manage. 4 PhDs, 2 professors, and we have also a balanced business experience to match this. We already acquired the ISO certification. The CE mark is one test shy, and the ATEX certification would come in 2027. So basically, we opened the seed round for $3.5 million. 2026, we will use it in order to fortify the cells of the ammonia and be with the hydrogen in the market, and 2027 be with all the combination of the different gases in the market, second revision of the ammonia system, and so on. Thank you very much.
Okay, so I'm going to talk to you today about a very ephemeral product called the electrode. What is an electrode? Well, it basically is the power source or underpins all electrochemistry, all electrochemical devices. So anything where electricity goes in this end and something comes out the other, molecules which are then turned into industrial gases on which we have hundreds of billions of derivatives annually, the electrons that power your advanced batteries, supercapacitors, sensors, it's all about the electrodes. I could spend a whole day talking about the sectors that depend entirely upon these electrodes, and it's no understatement to say that without electrodes there is no modern knife, there is no industry. Now, whoever has the best electrodes gets to determine the winners and the losers, not only at the equipment layer, and the equipment layer could be electrolyzers across more than 19 separate industrial verticals in traditional electrochemistry, which alone last year consumed 600 terawatt hours of electricity, the biggest consumer of electricity in the world. But also, as I mentioned, the derivatives above that. Everything is an inverted triangle balancing on the electrodes. And what we have is the first new process, industrial process, to make these electrodes that has come to market since 1963, and before that since 1882. So this is a generational change and a replacement for existing electrodes. What you can see here is the world's first fully automated continuous production line for electrodes in Barcelona, making industrial electrodes for hydrogen and chlor-alkali sectors. And again, some pictures of the team. Now, we came out of the Institute of Chemical Research based in Tarragona, in Catalonia. It's ranked top 3-4 in the world for pure research into catalysis and electrolysis. And this is one of their first ever spin-offs in over 40 years. On the left, you can see under the microscope what a traditional electrode catalyst layer looks like. On the right is a Jolt catalyst-coated electrode. We're talking about a fundamentally different beast. The difference between wrought iron and Bessemer steel in 1842, the difference between a transistor and an integrated circuit. This is a generational change in electrodes with enormous differences. We beat all existing electrodes on every single parameter: durability, energy efficiency, scalability, speed, metrics, consumption of precious metals. Now, we're moving the production of electrodes from batch during days, very, very energy intensive, precious metal intensive, labor intensive, to something that is McDonald's. It's fully automated, no humans involved, very low cost. Our factory most of the year runs off the solar panels on the roof of our building. Very clean, very safe. What we have is a combination of both a 1-minute coating process compared to days coating, which is the data from that is looped into our own reinforcement learning platform, which allows us, I think we're quite unique, we're the only ones that I know of that are able to immediately in the physical world recreate, test, and then loop back the results and the data of the candidate catalysts produced in the digital world.
Good evening, everyone. My name is Julio Diaz. I'm CTO and co-founder of Dipneo. I will introduce you in our world of developing an automatization device for ventilation for patients with out-of-hospital cardiac arrest. So we found that all around the world, there are 5 million people suffering out-of-hospital cardiac arrest yearly. Additional to this, only 10% of the people survive. Additionally to this, mouth-to-mouth ventilation has been removed from the guidelines for resuscitation procedures, and it has been proven that a correct ventilation improves up to 3 times the clinical outcomes of the patient suffering cardiac arrest. So in Dipneo, we want to increase this 10 up to 45%. The survival rate is our rate goal. So we are developing an automatization device. We are in the middle of 2 worlds. We are not a manual resuscitation device, but we are not electromechanical. So we are a combination of both. And we have many competitive advantages, such as our device is autonomous and hands-free. It's also easy to use. Once the user turns it on, press the button to start, and it controls everything for the ventilation of the patient, controlling different variables, such as pressure, volume, time, etc. Also, it's so light and portable, and it's so cheap compared to the advanced electromechanical ventilation devices. So our goal is to be placed by the side of this automatic external defibrillator, since we are a device focused for professionals, but also for non-professional users. So we can be the perfect complement to being part of this ecosystem of saving lives. So our system is based with 4 different blocks. First is the physical device, is the automatization of the ventilation. Second is the mobile phone, connecting directly in real time with a medical platform, receiving and sending data in real time to monitor the patient activity. Talking about our market, we are comparing directly with these automatic external defibrillators. So we have a huge market overall in Europe and in America, North America. Our business model is going through external distribution network, going directly with these distributors of automatic external defibrillators, but also going directly with public and big institutions. Our sales proposal is based on the direct sales of the device, also a service platform analyzing and comparing different data from the patient. And the user needs is our center of our value proposal. Talking about our intellectual property, we have a patent. We licensed it. We have done a product validation, and we have signed many intention letters of distribution with potential distributors of automatic external defibrillators. Okay. We raised 1.2 million euros now, and we are looking for an open round for 350K. We have already compromised 200 of them. So we invite you if you want to invest. We are the startup coming from MWCapital. It's a technological center, and we have been developing this technology for 3 years. We are now in the industrialization phase. We have a huge team inside of our company. We are 4 people working inside of the company, and we have many important providers for industrialization, development, and regulatory. Thank you so much.
Hello everyone, my name is Alejandro Rueda and this is Deep Detection. So X-ray inspection is present in many of the world's biggest industries besides medicine. You might know it from security in the airport when you go through your luggage, but it's also very important in the food and beverage sector for safety and quality. In the automotive sector, it's growing very fast for battery inspection, and of course in recycling and mining for separation of materials. But the key of every X-ray machine is the detector, is the heart of every machine. It's the one that determines the signal and the information that you get. What's the problem? That the technology that drives the detector hasn't changed in over 20 years. It's called scintillator technology. So how it works is that the X-ray projects the gamma ray or the X-ray on the product, and you get a shadow of the product. That's what you get. So these images are blurry, and for example, in food, it's very easy or very difficult to identify contaminants. So you have very high false positive rates and a lot of waste. This, of course, creates a lot of problems for companies, money cost in lost product and money lost in returns of products. So what's our solution? It's Photon AI, where we basically change X-ray from black and white to color X-ray. This is also a generational change, and it's a technology that has already been implemented in medicine with quite a great success. So as you can see, we can separate the materials because we identify and we count the photons that go through the material, and we can separate them into different energy levels. And thus, we can separate what is the product from the contaminant. Like in this example, this is a piece of chicken, and you can identify a piece of glass or a piece of bone inside of the product. Here's a few examples. On the left, you have a few cashews with some contaminants. This is what X-ray sees. Usually, on a production line in the food and beverage, this goes at a speed of 100 meters per second. And with our software, you can detect it, with our hardware and software, you can detect it instantly. Same with fusilli, very difficult, one of the biggest problems in the industry, and you can easily separate the contaminants. Another example with muesli. How do we do this? As I explained before, with photon counting technology. We count every single photon, and then we separate the energy levels. We also have an AI smart module that we integrate into the detector. We have a spectral material library that allows us to identify what we're looking for. We design everything from the ASIC. This is very important because we own all the IP from the core, the ASIC. We have all the AI models, and we have global patents in the European Union, in Japan, in China. What we do is the final product and assembly. We don't produce the detectors. We don't produce, the sensor boards. These are done, and the same as the wafers, these are done with our partners. So we're a fabless company. This allows us to be capital light and be able to grow very fast and with very good margins. So we launched the first product to market last year. This is the Photon AI DS. It's dual spectra. It means that separates into 2 energy levels. We won the EU Product Safety Award, the Gold Award, the highest in the category last year. And this already has been very well received by our clients, which are OEMs, mostly in the food industry. This year, we're launching our next product, which is the Photon AI QS, Quadra-Spectra. This will be the first multispectral detector in the world, meaning that we will be able to detect up to 4 energy levels. And the AI Smart Node that will be key to make this technology easy to use for our clients. As I said before, this technology already has been validated in the medical sector. What is the difference? In medicine, the patient can stay put for 5 minutes while you take the X-ray image. This is very important to get all the information. While in industry, you need to go fast and at a very good price. These are the 2 challenges that we managed to solve. We have a validated market pool. We're working with about 9 OEM partners. Some of them are some of the biggest global OEM in the food industries. And they are very happy with what they're seeing with the product and the roadmap of the technology we're going through. As I said before, we started in food and beverage. That was our beachhead due to experience our founders had. Next year, we want to move into security and recycling. This is what our next product will enable us to detect. And then we want to move on into materials, battery inspection, and mining. We have a team of over 20 people. It's a great combination of industry veterans with science. We're a spin-off of the IFAE and funded with some of the best funds here in Spain.